Hi guys, Digital Principal and Computer Organization. The subject code is CS3351. In this video, I am going to explain you what is mean and magnitude comparator. The first topic in this video is magnitude comparator. What is meant by magnitude comparator? It is a type of combinational circuit that compares two input. Okay, that compare two digital or binary number in order to find out whether one binary number is equal or less than or greater than the other binary number. For example, if you are going to give two input, either it may be A and B, or it may be X or Y. Okay. This will be the two input of the magnitude comparator. This magnitude comparator is going to perform the operation. Compare this both the input. Either the A is equal to B or A is less than B or A is greater than B. So this is the condition of magnitude comparator. It's going to compare the given input with another input. This is the block diagram of magnitude comparator. Here we are giving the two input A and B, and it's going to provide an output as comparison between the given two input. First one is whether the given first input is greater than the second input, or both the input will be equal, or either the first input is less than the second input. 1 bit magnitude comparator. In 1 bit magnitude comparator, it has two inputs. One is A and another one is B, and each consist of single bit values, and it's going to provide the three output. First output is A is less than B, A is equal to B, and A is greater than B. As usual method to fill the truth table, the A column is filled with 2021 and B column is filled with 0101. Now find out the first call output. A is less than B. Compare the first two values. When A is equal to B, B is equal to when A is equal to 0, B is equal to 0. A is greater than 0, less than 0. If it is true means the condition is true means you need to fill the, if the output condition is true means you need to fill the output as 1. Okay. If the condition is false, you need to fill 0 as the output. First condition is A is less than B. If you compare these 0, 0, both will be equal. So here you need to fill the condition is false. So you need to fill here 0. Next value is A is equal to 0 and B is equal to 1. This condition is A is less than B. This condition is true. That's why you fill 1 in this cell. And A is equal to 1, B is equal to 0. Here A is greater than B. So the A less than B condition is false here. If the condition is false, you need to fill 0. A is 1 and B is 1, the condition is false. Here you need to fill 0. Like that, you need to fill the another output as A equal to B. The first two values A equal to 0 and B equal to 0, the condition is true, so you will fill here as 1. A is 0 and B is 1. Here the condition is false, so you will fill here 0. And the third value A is equal to 1 and B is equal to 0. The condition is false, so you need to fill 0. And the final value A is equal to 1, B is equal to 1. The condition is A equal to B. Both the values will be equal here, so you need to fill here 1. The condition is true. The last condition or the last output of the 1 bit magnitude comparator. A greater than B. A is equal to B and B is equal to A is equal to 0, B is equal to 0 means the condition is false. So you need to fill here 0. Next values, A is equal to 0 and B is equal to 1. This condition is also false and you need to fill 0. Third value, A is equal to 1, B is equal to 0. Here the A is greater than B. The condition is true. Fill 1 here. A is equal to 1, B is equal to 1. The condition is false. So fill 0 here. The condition is false. With the help of this truth table, we can able to derive the equation for 3 output condition. First condition is A is greater than B. For A is greater than B, this condition only true. Okay, in this condition, the A is mentioned with 1. So you need to mention the A as it is. Afterwards, the B is equal to 0 in this condition. So you need to fill here B dash. And A is less than B. For A is less than B, the condition is true in when A equal to 0 and B equal to 1. Need to write the equation as A is less than B equal to A dash into B. A is equal to B. Here we will have two values as satisfied this A equal to B condition. So write this equation in the sum of product method, that is A dash B. The first value is filled with A dash B dash plus, and the next one value is filled with AB plus AB. Okay. This is the output expression for that I already explained you in this previous slide. So we will fill this equation with the help of sum of product form. If A is equal to 1 means you will mention as A. If 0 means you need to mention with A dash. This is the logical diagram of magnitude comparator. First, the B is connected with the NOT gate. Afterwards, and one more NOT gate is connected with the A. So A is less than B. Means here the one of the input will be 0 and another input will be 1. If you give 0 1 here, you get an 0 as output. If you give 0 here, you will get 1 as output. That's why the one of the end is connected with the normal A input. So here you will give either 0 as the input or 1 as the input. Like that, this condition is A greater than B. For A greater than B, we used AB dash. See here, this is A B dash. You need to draw the logical diagram for this equation, for this characteristic equation. All will be given in the product form, so you need to use and gate for to draw the logical diagram for this two expression. Okay, for A less than B, you need to draw the AND gate, and B greater than B, A greater than B, you need to draw the AND gate. Here in both the equation, there will be a mention of A dash and B dash. That's why you need to include the NOT gate here to represent the logical diagram. Expression for A equal to B is A dash B dash plus AB. So this both is connected with the AND gate with, and this is with AND NOT gate, and this both is connected with the help of OR gate. This gates will be used in the logical diagram. So A equal to B is A dash B dash plus AB dash. So the plus is the addition term, and for addition you need to use this OR gate. Next comparator is 2-bit magnitude comparator. In 1-bit magnitude comparator, you will have two input variables. In in 2-bit magnitude comparator, you have 4 input variables, but the output will be the same as 1-bit magnitude comparator. You need to compare the 4 input values, and you need to compare that either A is greater than less than B, A is greater than B, or either A is equal to B. Here the 4 input is mentioned with A1, A0, B1, B0. This is the truth table for 2-bit magnitude comparator. With the help of this truth table, you need to derive the characteristic equation and the K-map. So for A, you will have 2 input, A1 and A0. For B, B1 and B0. It has 4 input values, so you need to first fill the first input value with 8081, and the next column with 4041, and the third column with 2021, and the final column, that is B0 value, with 0101. First condition, or either the output is A less than B. Here consider A1 value is 0, A0 value is 0, B1 value is 0, and B0 value is 0. So the condition is false. If the condition is false, means you need to fill the value as 0. If the condition is true, you need to fill the value as 1. In second value, A1 is equal to 0, A0 is equal to 0. Finally, the A value is considered will be with the 0. And B value, B1 is 0 and B0 is 1. The B value is here 1. Compare the both the value, and A is less than B. So the condition is true. So you need to fill the value as 1. And for third value, A1 is equal to 0, A0 is equal to 0, and B1 is equal to 0, and A0 is equal to 0. Here also the condition is true. The A is less than B, because in both the A values the value will be 0, but B1 and B0, one of the B value as 1 as the input. So the condition is true. You need to fill the value as 1. Take this value when A1 equal to 0, A0 equal to 1, and B1 equal to 1 and B0 equal to 1. First of all, consider if we add this both the number, means if we will have only one of the A value as 1. Here we will have two B value input value as 1. It means the A is less than B. The condition is true here. Okay. The same condition will be applied to all the input value to find out the condition A is equal to B and A is greater than B. A is equal to B. Consider all these 4 value, A1 equal to 0, A0 equal to 0, B1 equal to 0, and B0 equal to 0. All the values will be 0, and finally the A is equal to 0. The condition is true. That's why you will fill 1 here. With the help of this truth table, you need to draw the K map and find the equation for all these 3 output or all these 3 conditions. The output expression is written in the form of sum of product method. In sum of product method, you need to mention 1 for A and 0 for A dash. The same condition is applicable for B2. A dash. Okay, the output is returned only when when logic 1 is obtained. First condition is, our first output is A less than B, right? When we will get an 1 when A is less than B. We will get totally 1, 2, 3, 4, 5, 6. 6 1 here. Okay, 6 1 here. The first one we will get when A1 equal to 0, A not equal to 0, B1 equal to 0 and B not equal to 1. This value is mentioned with A not, A1. A1, sorry, this is A1, consider first value as A1. So this value will be A1 and the second value will be A naught. And B1, the column will be mentioned with B1 and B naught. So this value, first value is B1 and the second value is B naught. As usual, the same procedure to fill the K map. The K map is filled with the, this is the gray code. Okay, the column and rows is filled with the gray code. Fill the 1 with the help of the truth table. When we will get 1 as an output, the condition is A less than B. First one, when A1 equal to 0, A not equal to 0 and B1 equal to 0, B not equal to 1. Afterwards, we will get an 1 when A1 equal to 0, A not equal to 0, B1 equal to 1 and B not equal to 1. Like that, you need to fill all the 1 with the help of that truth table. Afterwards, you need to do grouping. You can able to do here 3 grouping. One is, first group is this. These 4 ones will be grouped together, and afterwards these 2 ones we can able to group together. Then finally group this one. After the cancellation process, you will get an equation like this: A1 B1 A1 dash B1 plus A1 dash A naught and A naught dash B naught plus A naught dash B1 and B naught. You need to separately write group 1. So this is a K map for when A is equal to B. You need to fill this 1 in the particular cell with the help of the truth table. When A naught is equal to, as I mentioned you before, this is the A1 value, A naught value, and this one is B1 value, B naught value. Okay, when both 4 values will be 0 means the condition is satisfied, so you need to fill 1 here. Likewise, you need to fill all this 1 with the help of the truth table. Afterwards, you need to do the grouping. So in K map the condition is we can't able to group when the ones are diagonally placed. In this K map we can able to do 4 grouping. Group 1 separately. So these are all the 4 group. So first one is mentioned with the equation of A1 dash, A naught dash, B1 dash and B naught dash. And this one is filled with A1 is equal to 0 means you need to fill as A1 dash. And A naught value is 1, so you need to fill as it is A naught. And here in this one the B1 value will be 0. So you need to fill B1 dash. Afterwards the B naught value is 1 here. And the third one equation is both the value will be 1, so you need to fill here A1 A naught and here too 1 1. So B1 B naught. And the last one is placed in the cell of when A1 equal to 1, so A1 and a naught equal to 0, so a naught dash, and b1 equal to 1 b1, and b naught equal to 0, so b naught dash. This is the K-map for the condition when a greater than b. When a greater than b. Fill the 1 with the help of the truth table. Afterwards, derive the ex- expression for condition when a greater than b. Afterwards, we will group all the 1. We will get a final equation as y equal to a1 b1 dash and plus a naught b1 dash b naught dash plus a1 a naught b naught dash. Here we will group this 4 1 as one group. Afterwards, this one and this one will be another group, and this both the vertical one will be third group. Application of magnitude comparator, where the where we will use this magnitude comparator. So the magnitude comparator is used in the CPU and microcontroller. It is also used in servo motor controller, and it also used in the biometric application and password verification.